All right, students, so this is lesson 7.2, which is talking about angles and angle measure. On Monday we did 7.1, and today is Tuesday, May 17th, and I am not at school. You are expected to watch this video, complete this page, as well as the practice page on the next. So this is all notes, and then you have a practice page, okay? This is your work for today. So if you don't get it done, you're going to miss out on this lesson, and you're probably going to be very confused on Wednesday, Thursday when we actually start talking about the unit circle and trig. So we need to talk about angles and angle measures, specifically in the quadrant plane. I'm sure you guys have seen angles before, maybe when you were in middle school, maybe even possibly elementary school, where you had a protractor and you were measuring them. Kind of a similar concept, okay? So, but specifically we are going to use our 4-quadrant plane. So really quick, I'm going to go ahead and label these quadrants. This is 1, 2, 3, and 4. You need to know the quadrants, okay? What is an angle? Specifically, an angle is a rotation of a ray about a fixed point. You guys know what an angle is. You know what an angle looks like, okay? But specifically, it's a rotation of a ray. So let me get my pens ready. Hold on. Okay. So you guys know what an angle looks like, right? I'm going to just draw this on a coordinate plane. Okay, so I have an angle. This is my angle. And we talked about the angle being called theta. That's what we use to refer to the angle. So there's this angle. It's made out of 2 rays. So you have your initial side, which is, as you can see, laying on the x-axis. This is stationary. What does stationary mean? Stationary means it does not move. You will always have one side of your angle laying along the x-axis, stationary. That's the initial side. The other side is the terminal side. And this is the side that rotates. Okay? So the terminal side rotates. So imagine I had my ray laying on top of each other. When both arrows were pointing this way, it was 0 degrees. And then 1, 2, 3, 4, we start moving, and maybe we're at like 60 degrees right here. So my angle theta, my top ray has moved to the 60-degree position. This is my terminal side. This is the side that rotates. Your initial side stays stationary on the x-axis. And it always connects to your vertex right here at 0, 0 as the initial point. The vertex point is at 0, 0. Remember, vertex is like the corner. Okay? So that's just the general form of an angle. Now, there are types of common angles that happen from this knowledge, okay? We have now, you still have quadrant 1, 2, 3, 4. Now we're going to start talking about these quadrants in degrees. Remember I said if the rays were laying on top of each other, you were at 0 degrees right here. So what would all the way up at y be? Hopefully you would notice there'd be a little right angle right here. So up at y would be 90 degrees. Rotate down this way to the negative x position, you would be at 180 degrees because it would make a straight line, one ray going this way and one ray going this way. If I go 90 more, I'm at 270 degrees. And then when I go 90 more back, I'm at 360. And think about if I had a little circle in here, all the way from starting at x all the way back to x would be 360 degrees. So this is 0, and it's also 360 degrees. If I went around again, I'd be at 720 degrees. If I went around again, I would add another 360 to it, etc. So I'm going to draw an angle in here, a positive angle. I have my initial stationary side right here. Initial stationary side, and I'm just going to draw it right here. It's an obtuse angle, okay? Positive. I've started at my initial stationary side, and I have moved left, okay? So this is theta, this is positive, and I'm just going to say it's 120 degrees, roughly, between 90 and 180, okay? So again, your two rays are kind of on top of each other. Your terminal, so my two rays are on top, that's 0. My terminal ray starts rotating counterclockwise. It's going positive, okay? Rotation is, as I just said, counterclockwise. If you need to write that out, please do. Please pause the video and do. The arrow is on top. And when I'm saying arrow, I'm kind of talking about this arrow, this little blue arrow I drew. Okay, that arrow is on top of the x-axis. So what do you think that means for negative angles? If this is still 0 degrees, okay, I have my initial side that's stationary. When I'm going negative, I'm just going to start, I think, with the rotation. Rotation is clockwise this time, guys. So I'm going this way. So from 0, I'm going negative, though. This would be negative 90 degrees. Pop up here, negative 180 degrees. Pop up here, negative 270 degrees, and come back around negative 360 degrees. It depends on which way your arrow is moving. So when I draw an angle here, and I have moved this way to get theta, I've moved negative in a negative direction. My arrow is underneath now the angle, and let's just say this is negative 120 degrees. So do you see the difference? Hopefully you do. I'm going to act like my two pens are my rays, okay? Positive angle, I'm going counterclockwise. And then negative angle, I'm going this way. This one's stationary on top, and I'm kind of going under. And then positive, this one's stationary on the bottom, and I'm kind of going this way, okay? So that's the difference between positive and negative angles. Now, we're going to use reference angles, okay? And it could tell you if it's a positive number or a negative number. So for example, positive 270 degrees is in the same position as negative 90 degrees, okay? Positive 120 is in the same position as this negative angle right here, which I think is like negative 210. It just depends on which direction you are moving. The last one we have is quadrant angles. So these are just angles that lay on a quadrant. So you have, here's your vertex still. When your two rays are spread out left and right, what was that over here? If you remember, that was 180 degrees. If I go counterclockwise with theta, it's positive 180. Now, if I made an indication I went clockwise, I'd be at negative 180, okay? And then same thing here to here or up above. Obviously, that is a 90-degree angle. This would technically be, if I'm going this way with theta, a negative 90-degree angle, okay? The terminal side, remember that's the side that rotates, falls on the x-axis, like 0 degrees, positive or negative 180 degrees, and positive negative 360, okay? Or it can lay on the y-axis, like positive negative 90 and positive negative 270. So the terminal side, quadrant angles are when the terminal side falls on either the x-axis, it's 0 if it was here, 180 if it's over here, and then 360 if it's back where the 0 is. And then you have the y-axis as well, 90, negative 90, and then 270. Okay, hope that made sense to you. So this is all what we're pretty much talking about. Okay, now we're going to talk about converting from degrees to radians. Radians is something you're going to have to understand, especially going into higher level math. Radians and degrees have a special relationship. Radians make it possible to relate linear measures, so like numbers, okay, 1, 2, 3, to whole numbers, decimals, etc., to degree numbers, 90 degrees, 270 degrees, 180 degrees, etc. So we have to be able to convert between these two. And radians uses pi, and then degrees is obviously like your whole numbers with your little degree sign. So there is a little bit of a formula here, okay? If we have the degree, you're going to take the degree, whatever that is, times pi over 180. And we're going to be leaving the pi symbol, okay? That's going to give us something pi radians. So divide by 180 and reduce if you need to. So, for example, 45 degrees. I'm going to do 45 degrees times pi over 180. So this is the same thing. Put the 45 up top as 45 pi over 180. And we're going to reduce if we can. Think of your GCF, your greatest common factor that these two numbers have in common. You might think it's 9. But when 45 and 180 are both divisible by 9, you still have a factor of 10 there. So it's actually 45. 180 degrees is actually, or 180 is actually divisible by 45. It's 4. So ultimately this would come down to pi over 4. You try B and come back to the video and see if you got it correct. So hopefully you pause the video. 300. So we would do 300 times pi over 180, which is 300 pi over 180. And then both of these are divisible by 60. You could think of 6, but 60 would get rid of the 0. So if the top is divided by 60, we would end up with 5 pi, and then the bottom divided by 60 is 3. So you need to leave it in terms of pi. So degree times pi over 180, okay? To convert from radians to degrees, if you have the radians and you need to go to degrees, you're going to do whatever the radians are with pi times the opposite of what we were doing before, 180 over pi, because we need to make the pi go away. So if you can kind of remember this, degrees on the bottom, degrees on the top, pi on the bottom, to go to the other version. And that's going to give us our answer in degrees. So cancel out the pi and then multiply the fraction by 180. So for A, we have pi over 3. I'll keep it going in red, I guess. So I would do pi over 3 times 180 over pi. The pi's would cancel. The fraction here would basically be 1/3 times 180. And if you do 1/3 of 180, you get 60, and we are in degrees. Go ahead, pause the video, try B on your own. Come back to the video to check. So we have 5 pi over 6 times 180 over pi. The pi's would cancel, leaving me with 5/6 times 180. And you can just do that in the calculator. You get 150 degrees. Okay, so Miss Wallace, why do I need to use this? Well, most students like working in degrees, especially to draw angles. So I'm going to, down here, convert all of these into their proper degrees. So I need to know how to do that. Some students very rarely like working with degrees, or like working with radians. But you do need to know, maybe your question was given to you with degrees and the answer choices are in radians, and vice versa. So make sure that you can convert between the two. So I'm going to do like A and B, then I'll pop over and do D and E, and I want you to try to do C and F, and then I'm going to keep playing it in the video, so you can always check your answer. Okay, so for example 1, you want to draw each angle in standard position. It means what it's saying. If it's saying -212, I need to draw it with -212. And then that's all we're doing here. And then draw the arrow of the angle's direction. So let's get green. 48 degrees. So and remember, if you want to use this to help you, this is 0, 90, 180, 270, back to 360 in the positive direction, and this direction one's positive. This one's negative, so 0, negative 90, negative 180, negative 270, negative 360, just so you know roughly where the arrow goes. So it doesn't have to be absolutely perfect, guys. So 48 degrees, initial side, terminal side, the arrow would be going this way to get there, okay? 48 is roughly halfway between 0 and 90, so again, doesn't have to be perfect. Negative, so initial side. Now my terminal side, I need to go clockwise this way with it. So I'd bring it around and I would end up somewhere up here. But when you go to draw your arrow, you're going to draw it this way, okay? Because I'm going negative. So that's negative 212. You can go ahead and pause the video and do C. All right, so hopefully you paused the video and did C. 270 degrees, since I drew the 0, 90, 180, 270, I kind of have an idea of where it is. So initial side, terminal side, and my arrow to get there would be going this way. Okay, now is the fun radian part. Again, we're going to learn about radians on the unit circle and actually where these would show up, but the easiest way to do it right now is to convert them into degrees. Multiply by 180 over pi, pi goes away, multiply basically 4/3 by 180. So 4/3 times 180 is 240 degrees. So my angle would be roughly here, because 180, 270, it's positive, and my arrow would go this way. Negative pi over 6, so the negative would go away. So essentially you're multiplying by negative 1 over 6 to 180, and that's going to give me negative 30 degrees. So initial side, terminal side, this way is negative 30. Try the last one on your own. So this is basically negative 1 times 180, so negative 180. And positive or negative 180 is just going to be a straight line right here, but your arrow needs to know where to go. So my arrow is going to be going this way because it's negative. Okay. So now that we kind of have an idea of where these angles are ending up in the direction that these angles are going, we're going to be talking about coterminal angles. Different colors. Coterminal angles are angles that share a terminal side. So remember, guys, I talked about how this goes all the way around to 360, but I could basically go around again and get 720 and again for a third time and add on to 360. That's creating these coterminal angles. So super simple. To find a positive coterminal angle, add 360 degrees. And notice it says if in degrees. Or add 2 pi if it's in radians. Now you could convert to degrees first and then just add 360. That's what I personally would do, but I'll walk you through how to do it if it's in degrees. All the way around ends up at 2 pi, and again, we're going to get into that in the unit circle more later. If you want to find a negative coterminal angle, you're going to subtract 360 degrees or subtract 2 pi if it's in radians. Or again, you can convert the radians, which I would suggest doing, and then do your degrees. Coterminal angles can contain multiple rotations, because if we go bigger than 360, then we're going to be going past that 360 point. We're going to have to keep going. So I'm going to call these swirlies in our notes. Okay? So example 2a, find a positive and negative coterminal for the given angle. Very straightforward with I, positive coterminal angle. A different color. We're going to do 60 plus 360, which is 420 degrees. And then negative coterminal, 60 minus 360. Notice it's not 360 minus 60. You start with the angle that they're giving you. So 60 minus 360 gets us negative 300 degrees. Okay? Now, I'll show you to do it with radians, but like I said before, you could switch this to degrees. I think that would be so much easier. So remember, if I wanted to switch this to degrees, I would get rid of the pi essentially and multiply the fraction that's left by 180. So I'm going to do that really quick. And we get 210 degrees. So this would essentially branch off if I add 210 plus 360. I get 570. And if I do 210 minus 360, I get negative 150 degrees. But just to show you guys with radians. Now, if I want to add 2 pi to it, remember if I'm adding or subtracting fractions, I need to have the same denominator. So 2 pi would essentially be 12 pi over 6, since this is in sixth. So I would essentially be doing 7 pi over 6 plus 12 pi over 6. This is equal to the 2 pi. And I would end up with 19 pi over 6. And then I would do the similar thing with the negative. I would be doing 7 pi over 6 minus 12 pi over 6. And I would get negative 5 pi over 6. So that's how you would do it with radians. I think degrees is a lot easier, but that's just me, if you can remember how to convert. Okay, next page is we're going to actually draw the angles. So example 2b, we're going to find and draw an angle between 0 degrees and 360 degrees. That's coterminal with the given angle. So we have to be between 0 and 360. And what's going to happen is we're going to end up with these swirlies. Okay, so basically, guys, what you're going to do is see how many times or how many 360s you need to take away from these numbers or add to the numbers to get us a number between 0 and 360. So, for example, let's see, I'm going to turn off so I don't see text. If I'm starting at 1,116 and I minus 360, I'm still not between 0 and 360. So I'm going to minus another 360. I'm still too big. I'm not below 360. So I'm going to minus one more 360. And now I'm at an angle between 0 and 360, which is 36. So essentially I am subtracting 3 360s, three circles, which lands me at 36 degrees. So when you are going to draw this, where's 36 degrees, guys? It's about here. But when I draw this, I need to draw in my swirlies. How many times did I take this ray around and around and around the circle? I took it 3 times. So that means I'm going to have 3 swirlies. Okay? So starting here, 1, that's 360 degrees. 2, 1, 2, that's 360 degrees. 3, that's 360 degrees. So I have 36 degrees left, and I'm right here. So this whole thing with the swirlies shows me that it's 1,116 degrees. So 1,116 degrees. I hope that makes sense. Okay? Let me know on Tuesday if you need clarification, or Wednesday, excuse me, if you need clarification on any of this. My goal on Wednesday is to kind of do an activity with more practice with this, and also allow you guys to get help from me if you need it. Okay, negative 585 degrees. Now this time, since I'm negative, I'm going to have to add 360 to get myself positive angle between 0 and 360. So let's start with 595 and make it negative. Add 360 once. I'm still at a negative. Add 360 again. Okay, now I'm between 0 and 360. And if I try to add 360 again, I'm going to be too big. So I'm going to stick with this 125. Now, where is positive 125 going to end up, guys? it's going to end up right about here. So 90, remember, 180, write those in if you need it, 0, 90, 180, 270, 360. But again, you have your swirlies. So to show the math, I added 2 times 360, which ended me up at 125 degrees. And that means I have 2 swirls. So again, starting here, but I'm going negative, so make sure you go clockwise. I go around, that's negative 360, swirl 1. Okay, so since I added 360 twice to get to a positive coterminal angle, I have to make 2 swirlies. So I have my starting, that's 1 swirly, 2 swirlies, and then stop here at negative 585. So again, I start here, I go negative 360, so I take a negative 360 off, so I'm at negative 225 still that I need to go. I need to go around once more, and then I end up at my 125. Now you're not going to have to draw this on the EOC. You're probably going to have more questions like the coterminal angle, okay? But I want you to understand this again for the unit circle that we're going to get to later. I keep saying that that's going to be really confusing, so try to nail this and ask me questions if you have difficulties with it. Okay, now we're in radians. Again, I would personally transfer these into degrees to help you. So if we have 10/3 pi, get rid of the pi, multiply by 180, reduce. You don't even need to reduce here, you just do 10/3 times 180, duh. And you end up at 600 degrees. Okay, too big, so, and it's positive, so I'm going to be taking away 360. How many 360s do we need to take away to get between 0 and 360? Whoops, 600 minus 360 is 240. So I only need to take away 1 360 away to get 240. So that's going to be my coterminal angle. And I need to do 1 swirly. Now, I do want your answer. I should have put that on here. Our answer should be back in radians. So again, you can multiply this by pi over 180 and reduce to get yourself in radians, which is 4 pi over 3. So let's draw first where 240 degrees would be. 240 would be roughly here, okay? And we have to do 1 swirly. So starting here, we're going in a positive direction. So we go around 360 and then around to get to 600 to the 240 reference angle or the 4 pi over 3 coterminal. All right, negative 49 pi over 12. So if I first multiply that by essentially 180, I end up with negative 735 degrees. I want an angle between 0 and 360. So let's see how many 360s I need to add to that. Negative 375 plus 360. That's 1, still negative, plus 360. 2, still negative, plus 360. 3. So I need to add 3 360s, which means I'm going to do 3 swirlies to get a positive 345 degrees. So I am adding 3 360s, so 3 swirls, to get 345. Again, to put this back into radians, multiply by pi over 180, reduce, you end up with 23 pi over 12, and that's your radian answer. Again, 3 swirlies, so draw where 345 degrees would be. It'd be here, you're almost at 360. Remember, this is 270, 0, 90, 180, 270. 3 swirlies in a negative direction. So 1, 2, 3, and then arrow. Okay. Example 2C is the opposite. Using the given picture, you're finding the measure of each angle. Again, keeping in mind if it's positive or negative, they give you a little bit of like a reference number to use as well. So I Aye, guys. Okay, so there's a couple of different ways that you could go about doing this. The way that I kind of saw to do it is, so I'm focused on my swirlies. How many times am I swirling? How many times am I hitting 360? Focus on kind of the angle that's left over. So for this one, for instance, I'm not even hitting 360 yet. This is telling me that from here to here is 120 degrees. And you guys should start seeing now that from here to here is 90. So out of that 120, if I've gone 90 here, how much more do I go 30 there? We know that right here is 270. So 270 plus 30 more would be 300 degrees. So essentially, it's a lot of kind of critical thinking, okay? I haven't gone around fully to 360, so I know I'm definitely less than 360. Over here's 180, okay? You could also do 180 plus 120. That's totally acceptable as well. Out of my 120 to get to the y-axis down here, I've gone 90, so I have to go 30 more. So I did that 270 plus 30. You could have done 180 plus 120 and also gotten 300. 300 is your answer here. All right, let's look at II. So I have a little bit more of a swirl going on. So swirl all the way around is 360. So that knows I'm definitely doing 360. To get over here is 180. So I'm going to be adding 180. And then to go a little bit more is 40. So essentially these are the three numbers that I'm adding together. That gets me 580 degrees. You guys have, it's a little tricky maybe to see. So either, kind of draw those numbers and those swirls in from my video, or you also have the PDF on Canvas if you can't see the numbers and the swirls as well. Okay, III, little tricky because now we're going negative. So notice the arrow, the difference of the arrow, it's underneath. So that means you're negative, okay? All right. Starting point, go around once. I've hit right here, negative 360, that's one swirl. Go around again, hit again, that's another plus negative 360, you could say minus. And then I go around a little bit and I end up here. Now, from this direction, it tells me I've gone 175, but from this direction, I've gone 180, so plus a negative 180, and 5 degrees more in order to make that 175. So plus a negative 5. Now I know this looks confusing with the plus and negatives, but I just want to show you negative 360 plus negative 360 plus negative 180 plus negative 5. So in the calculator, you could do negative 360 minus 360 minus 180 minus 5. And you end up at negative 905 degrees. Okay. These last two are using radians. Again, I would suggest, that's a 5. I would suggest switching into degrees because I find it a little bit easier to work with. And then switching back into radians. All right, so this pi over 3 is essentially 60 degrees because if I multiply 1/3, because the pi would go away, by 180, I would get 60. So just think of that as 60 degrees. So I have swirled around a lot here. And I'm going positive because I'm going counterclockwise because my arrow's on top. So swirl once, 360. Swirl again, another 360. So 360, 360. We're adding. I go to here, I'm at 180. I go to here, I'm at 90. And then if this angle is 60 degrees, then this little bit left is 30 degrees because the whole thing needs to equal 90 to get to the y-axis. So adding all of that together, or you could do your 270 because you know this is 270, and I just did 180 plus 90. So I just broke it up that way. But adding all of this together, you should get 1020 degrees. Now switch it back into radians by multiplying by pi over 180. and reducing, so your fraction is 17 pi over 3 as your final answer. 17 pi over 3. Sorry if you can't read that. These pens are wonderful, but kind of a pain. 17 pi over 3 for IV. All right, last one, number 5. Again, this is a 2 pi over 9. I know it might be kind of hard to see. That is a 2. So pi would go away, multiply by 180. That's 40 degrees. So that little angle right there is 40 degrees. So we are going negative because of the arrow being under, going in a clockwise direction. So here all the way to here is 1. So that's negative 360. You could come over here and do negative 180. You could come up here and do negative 270. Doesn't really matter. A little bit more, negative 40. So you end up with negative 670, but transfer back into radians, multiply by pi over 180, reduce, and you would get negative 67 pi over 18. And I can show you guys how the calculator can show you a reduced fraction if you're not sure how to do that on your own. The calculator can do that reduced fraction for you. All right, last little bit here is reference angle. Reference angle is an angle B associated with angle theta, where B is an acute angle less than 90, less than 90 degrees, formed by the terminal side of angle theta and the x-axis. All right, what does that mean, Mrs. Wallace? So you can think of these as formulas if you want, but it's just kind of critical thinking skills. If the angle falls in quadrant 1, so your angle is here, and I want an acute angle, okay? So if it tells you about a reference angle, angle B, we're calling it B, associated with angle theta, where B is an acute angle. So since this is already an acute angle, theta, we're going to call it theta, this would be your B, that reference angle that we're talking about. So B would just equal your angle theta here if it ends up in quadrant 1. If the angle falls in quadrant 2, so if you draw an angle in quadrant 2, something like this, obviously that's not a acute angle. So it's an obtuse where this is theta, okay? This little part would be B. So your little formula here is that B equals 180, because 180 is flat, minus the theta. That will get you an acute reference angle. If the angle falls in quadrant 3, so like this, okay? This is beyond 180 now, so here's your angle theta. Beyond 180, this little bit here to here would be your B. So this time I want to do theta minus 180. Again, not formulas for you to memorize, more so critical thinking, okay? Use your critical thinking skills that we've been trying to develop this year. And think about, like, okay, if this is, what's a number bigger than 180? 200. If this is 200 degrees, my reference angle needs to be less than 90 because it's an acute angle. So my little reference here is going to be 20 because 200 minus 180 is 20 degrees. Last one, if the angle falls in quadrant 4, so take your theta all the way around. This whole thing is B. And you know what? I should have done my arrow the other way. Sorry, guys. This way. That's B. So to get B, you would do 360 minus theta. Okay, what the heck, Miss Wallace? Why am I going to need this, etc.? So, find the reference angle B given an angle theta. Make sure angle theta is between 0 and 360. And it says that because you have some bigger ones over here that we're going to talk about. So A is 120 degrees. Where does 120 degrees lie? It lies in quadrant 2. So we use this one. The work would be 180 minus 120, and that is 60 degrees. So you would use reference angle 60 degrees. B, 53 degrees. So that's going to end up in quadrant 1, and B just equals the angle. So B is 53 degrees, so B is 53 degrees. Now, 948, remember the swirly, swirly, swirly from before? That's essentially what we're doing here. So first I need to swirly, swirly, swirly and get myself an angle between 0 and 360, and then I can do this process. So I'm going to see how many 360s I need to subtract from 948. 948 minus 1 360, still not between 0 and 360. Minus another 360 puts me at a number between 0 and 360. So I'm going to use 228 as my coterminal angle instead. So I'm going to use 228. And that's kind of the math that I drew over here. Okay? So now I'm using 228. Where does 228 lie? 228 lies in quadrant 3 because it's less than 270, which would be here. Quadrant 3. So we're going to do 228 minus 180. 228 minus 180 is 48 degrees. D, you have a negative, so you're going to be adding 360s to it to get yourself an angle between 0 and 360. I added 2 360s to get myself 315, so you can think of this as 315 degrees. That's going to lie in quadrant 4. Did you guys notice I tried to give you one of each quadrant so you would have an example? And then you would do 360 minus 315, and you get 45 degrees. Okay, I know that was probably a lot and overwhelming, and a lot of you might be confused, but please, please, please try the worksheet on the next page, because I think if you do some practice, and every single question section goes with something in the notes. So for each angle, draw the angle with a colored marker, color pencil, frankly pencil guys, or pen. See if a friend nearby has some. I'll leave my colored pencils out and tell the sub that you can use them. And make sure to include direction in your drawing. If the angle is more than plus or minus positive or negative 360, then indicate that with the swirlies. So this is very similar to example like 2B and 2C, okay? You're converting, so that's like the front page. You're finding the positive and negative coterminals, that's like the front page, and then you're determining the measure. Now I know this might be hard to see, so hopefully you've stuck with me in the video this long. I'm gonna go ahead and kind of help you out with what this looks like. So this is my little swirl, and this is 80 degrees. And then I have a bigger, this is a little easier to see for you guys, but I understand if you can't see the numbers. This is pi over 3. This right here, this was 80. All right, this is 55, and this is 3 pi over 4. I'm talking about this whole thing. And we swirl around, and we swirl around. And then the bottom, determine the reference angle. We just did that in the last example. So my honors kiddos, you need to do it all. My regular kiddos, you need to do, let's do evens. So regular, evens, odds, do everything. Or sorry, regular kids do evens. If you want to do everything, do everything. If you do everything, I'll give you some extra credit. So regular kids do evens. Honors kids, I'm expecting you to do everything. There will be a space in Canvas for you to turn this in. We will go over the answers Wednesday when I come back, and I plan to do an activity doing more of this and lesson 1 when I come back on Wednesday.